Welcome, everyone. Let's look at the first Finding Nemo lesson, day 1, lesson 1. I would start here for anybody just getting started or even anybody that seems to be going along with the Finding Nemo lessons and asking yourself if you're doing it right. So just start with lesson 1, day 1. You can find this on the Google Classroom in January assignments. The document that was posted on Monday doesn't seem to have formatted really well. So I don't want to delete the assignment in case anybody had worked in these documents. It would delete your work, but I wouldn't focus there. I would focus on the Google Slides. Please note that if you do not have access to Finding Nemo, then you can absolutely do this activity with any movie, but I'm hoping to develop a similar context, a common ground for everyone. So if you can, in the lesson 2 or day 2 on slide 3, I have found and pieced together the first 20 minutes of the movie with YouTube. I recently just added those links to the clips to the end of the day 1 slide, but those links will not show up in your day 1 slides that are in the assignment for each of you. Moving on. Let's just go through. So I'm going to take you through the lesson, the introduction, and then the next video will be maybe after page 8, but I'm going to go straight in order so that these videos will line up and you can just click if you need help. Welcome to Movie Mathematics. We will be featuring the first 20 minutes of Finding Nemo to practice collecting data, calculating statistics, using tools to help us solve these two problems, these two questions that we have about how do we collect data and how do we take that data and do some cool things to it using mathematics, and then what does that mean for us? So those are the problems. It's like asking a question, how do we collect the data for that? And then once we have it, what does it tell us? Part 1, we will practice some statistical calculations. I wonder if I should be, let's do this. I think you can see my mouse. So part 1, we will be practicing calculating the statistics, mean, median, mode, measures of center. These measures are used to help people see what is representative of a population or a sample. So measures of center, and like I love typing in Google because you can get quick. I go to images and I see what's going on here. Okay, so we have mean, median, and mode. Central tendency. This is a skewed histogram. You all can recognize this, which shows that the mode is way to the left of the histogram. Likely, the mean will be over here more because of these extreme values. The mode is here. The median is likely going to be to the left of the mean because the median is actually closer to the center when there's extremes or outliers or a skewed situation. So that was just a quick way that I recommend you all see. Here's a better picture of it. The mode is the steepest, this is what I was saying. Then the median is going to come next, and then the mean is going to be the measure of center that's closest to an outlier if it's skewed. When your data distribution is all centered, they're all going to be relatively close, and if you have some skewedness or like a long part, an outlier, then it'll manipulate the measures of center. Okay, here we see fancy definitions, but I need you all to believe in yourselves that you can make sense of this, okay? The central tendency is the tendency for a set of values to gather around the middle of a set. So this idea that when you collect data, if you collect enough of it, it'll all gather towards the middle, generally measured by mean, median, and mode. So now these are tools. Like you measure height with a ruler. Now mean, median, and mode are our tools in our toolkit, okay? So think of literally a toolkit. Okay, these are tools for our toolkit. Now, what are the tools in our toolkit. We have mean. Mean is the average. It is the sum of all values over, and when this word over is being used, it's messy. That should be divided by the number of values that you added up. Should be applied to continuous data if it's normally distributed. That means that we should use the mean when we have continuous data, not discrete data. We'll get into that. Discrete is what we're doing when we're counting tally marks of frequencies versus measuring with a ruler, which has continuous values in between. So is there continuous data, and is it normally distributed? So is it shaped like a bell? A perfect little bell. Median is the middle value of an ordered sample of numeric values. With average, we don't have to order the numbers from least to greatest. We need to find their total sum, and we divide that total sum by how many numbers we added up. Median, we don't add them up. We don't need their sum. Knowing how many there are is helpful, not necessary. We have to line up the numbers from least to greatest and then find the middle. If there's an even number of data points, which is why the n value or the number of data points is helpful, then we need to do a little bit of extra work, but we can totally do it. You find the sum of the two middle numbers. It's either one middle number or two middle numbers. If you have two middle numbers, you add them together and find their midpoint by dividing by 2, or you find their mean. If it's an odd number of values in the data set, you just find that middle number. Extreme values do not affect the median as much as the mean. For example, length of stay and house prices. Maybe if somebody length of stay and house price. I'm not sure what this, skipping that. Usually applied to numerical data unless it's normally distributed. So if a data set is not that perfect bell shape that's centered and symmetric, then you should use a median. In the case of over here, this skewed visual, you should use the median because that mean is going to get pulled way towards the extreme over here. It's not going to be representative of the numbers that it is meant to represent. It's not the center. It is the center in one sense, but it's not the center that allows your reader to understand where most of the data points are surrounding. More data points are over here by the median in this set than over here. But this center is still like a legitimate tool we can use. It just doesn't represent, it doesn't say what it should be saying. It can be misleading. Okay. The mode is the most frequent, and it can be used for skewed numerical data or categorical data. So categorical data is numbers that are describing your feelings. Like from a scale of 1 to 10, how much do you love to sing? That's like more categorical. And then furthermore, you could really just say like, do you love to sing? Do you sort of love to sing? Do you not have any feelings about singing? You don't like to sing, or you really don't like to sing? And that's super categorical. Or what's your favorite color? Or the surveys you all can have done asking questions of each other. So that's something you can find the mode for, but we can't add chocolate ice cream with yellow banana ice cream to make chocolate and yellow banana. I don't know, right? So that's a quick look at our toolkit for using mean, median, and mode, the measures of center. Next, I'm going to talk about measures of spread, which is some of your classmates have asked for.